Welcome to Unit 3.5. Things get interesting here. Alright, so this is the idea of looking at real world graphs, right? The x-axis is time in seconds, and the y-axis in this one is height in feet. And we're going to try to analyze what this graph is telling us, right? So the information says the graph shows the height of a roller coaster during a single ride. Describe the roller coaster ride. You just want to look at it and think about seconds passing and it getting higher in height and then lower in height and then higher in height and then lower in height and then seconds passing and then higher in height and lower in height and then seconds passing. You literally read the graph and try and figure out what it's telling you. So if I was to try to explain what was happening in this graph, I would say it begins, right, ground level, and then goes uphill very fast, and then at the top it drops quickly, right? So far this is it. It begins at the ground level and it increases and then drops really quickly, right? That's what it's done so far. And then I could say it increases but not as high. It doesn't go as high. It then increases, goes back up, but not as high. Drops down and goes level for a few seconds. And then how does it finish? It goes back up, still not as high as the first one. It then goes back up and then drops and levels out for the end. Right? So I could say the highest point of the roller coaster was here, and that it starts at the same level as it ends. I can tell you these things from analyzing the graph, right? That's a lot of information to get from this one little graph. Well, that's what we're going to try to do. We're going to try to learn how to analyze graphs. We're also going to take information that they give us and try to create our own graphs. Right? So, drawing our own graphs for some people is really easy, and for some people it's really hard. So, we'll take it slow. First one was to describe it. So I'm going to read you the second one, but you're going to try to fill it in, right? In a single day, it snowed lightly during the morning, then heavily for the rest of the day. Graph time on the x-axis and total snowfall amount. So snowfall. So if we wanted to do time, because it's going to go through the morning, we could do in hours or minutes. And snowfall, let's do it in feet, because you can measure it in feet or inches. It's your graph. You make it how you want it. And then draw the line of what that would look like if it was snowing lightly in the morning and then heavily for the rest of the day. What would that look like? What would your line look like? All right, let's do 3 together. Mia bought a painting. The value of the painting dropped by 25% after 1 year, that increased in value over the next 5 years, reaching a value that was twice what she had paid for it. All right, so graph time on the x-axis, and we're talking years, so we're going to call it years. Make the graph make sense for your picture, right? Make it make sense for the words. And the value of the painting on the y-axis, so we're going to do money. And it doesn't give us amounts per se, like not $5, $10. What it tells us is that there was an initial value and that it dropped by 25% and then increased and ended up doubling, right? So what we can do is just make up a number, or we could use percents. So let's say that the original value, let's call this the original value, let's say it was $100. It's a nice round number. And they don't tell you, so you can make it whatever you want. And then our time, right, this is when she originally bought it, so that's at 0. Actually, 0 should be here. Let's do that. Right, because that's where 0 is, your origin. Well, that's when she originally bought it. And then it says it dropped 25%. 25% of a dollar is 25 cents. So let's break it down into 50 and 25. So because we know it's going to drop here after 1 year, right? 1 year. And then increased in value over the next 5 years. So we know we needed to go 5 years, 2, 3, 5 more years. So it has to go up to 6 years. And then it's going to end at twice what she paid for it. So 100 is where we started, so we need to end at 200. You notice I'm not filling in all the empty holes. They're not necessary. I'm creating a graph that represents this information. So I'm only putting what I need. All right, so let's graph it, right? Let's graph it in a different color. Do this one. All right, so this is where she bought it, right, at 0 years for $100. She paid $100. After 1 year, it dropped down 25%. 25% means that it lost $25. That means it was worth $75 after year 1. Right? And then over the next 5 years, it increased, reaching twice. So by here, it was here at 200 twice, right? By year 6, it was at twice what she paid for it. Now, all we have to do is connect the dots. Right? This is what she paid for it. It went down in value 25% and then increased in value. Don't judge me, I can't draw a straight line. Right? So this is what it looks like. This is what that graph should look like. It started at whatever she paid for it. It dropped down 25%, which in this case was $25, and then increased to double what she paid for it. So you make the graph match the information. All right, 5. Jace is speeding on a highway and gets stopped by a police officer. The officer gives him a ticket and he continues on the highway. Graph time on the x-axis, so the amount of time, so we're talking about minutes because it's driving and then stopping to get a ticket and then driving again, so minutes, right? And speed on the y-axis. Speed. Right? And we're going to do it in miles per hour because, well, that's how we measure speed when we're driving. We do it in miles per hour. If you were in England, it would be kilometers per hour. Don't get me started. All right, so we know he's going to be speeding to get started. So at 0, right, at the very beginning of your graph, he's going to be speeding already. So if he's going fast enough for the officer to stop him, let's say he's going 75 and a 55. Why not? Because we can make it anything we want. They don't give us the numbers, we make the numbers, right? So then it says he stops by a police officer and gets a ticket. So somewhere around, let's call it 5 minutes. He does 5 minutes at 75 miles an hour, and he gets stopped by the cop. So his speed then is going to be 0, right? His speed here is going to be 0. How long does he get stopped by the cop? Don't get me started. All right, so it says he gets a ticket, so long enough to make a ticket. So we're talking, let's say 10 minutes passes. So now we're at the 15-minute mark. And for 10 minutes, he was stopped and going 0 miles per hour. And then it says, and then he continues on the highway. So let's suppose he speeds back up and he gets probably to 55, because that's the speed limit. Let's be logical. All right, and let's see if we can figure out how to graph this. So he started at 75 miles an hour. He stopped very quickly because, well, a cop pulls you over and that's what you're supposed to do. And then he sat at 0 miles per hour for 10 minutes. And then after he got his ticket, he sped up slowly. He sped up slowly so that he didn't piss off the cop instead of going very fast. And he stopped at 55 miles an hour. Right? He didn't take off with a spin of his wheels because that's just going to piss the cop off. That would look different on the graph. Right? So he stopped hard, spent 10 minutes at a dead stop, and then slowly went back up to 55. All you have to do is figure out how to represent the information. What does this look like visually? That's all we're doing. And not everybody's graph's going to be identical. The things that are going to be identical, time on the x-axis, because it told us to put time on the x-axis. Speed on the y-axis, because it told us to put speed on the y-axis. And the fact that we know he stopped, sat, and went again, it's going to have the same theme, but not everyone's going to be identical. Speeds are going to be different. Times are going to be different. How hard they stopped and how fast they started again is going to be different. So the graphs should probably not be identical. It's how you see that information. Alice drives the school bus. That's nice. On her morning route, she stops at every block to let students on. That sucks. Graph time on the x-axis. Again, we're doing time. And we're talking about stopping every block. So you want to do seconds? We could do seconds. Or minutes. Seconds or minutes. Completely up to you. And the total distance the bus travels on the y-axis. So we're going to call this distance. And we want to measure, we could measure in feet, but it's going to go a lot of feet. You could measure in yards, but that's still not good. You could measure in miles. That's a lot of miles though. Let's do miles. Miles makes sense because you are driving a bus. Let's do miles. All right, so it says on her morning route, she stops at every block. So you're going to time and distance. So if she starts at 0, 0, 0 time, 0 distance. And then she's going to drive for 2 minutes. And it's going to take her 3 miles. And she's going to stop. And then she's going to drive for 2 more minutes. And she's going to go 3 more miles. And then she's going to stop. Every block. Country block. Rural blocks. Right? And then she's going to go another 2 minutes. She's going to go another 3 miles. This is a fast bus driver. her bus ride is probably fun. You see what I'm doing? It's a pattern. 2, 4, 6, 8, 3, 6, whoops. 9, 12, 10 minutes, 15 miles. I'm probably exaggerating by saying she's going so fast, but don't panic. All right, so if she stops at every block and she drives the same, like, miles per hour, right? Then she's going to start here and she's going to stop here at this corner, this corner, this corner, this corner, this corner. Like literally it's going to make a beautiful line. It's going to make a straight line. Do you know what this means? Why we do this? We turn this into this because we can predict where she's going to be in 45 minutes. If she follows this pattern, then you know where she'll be in 45 minutes. Or where she should be, which means you'll know if she's ahead of schedule or behind schedule. This is how they predict when the city buses are going to get where they're supposed to get. Graphs. All right, and now you see why I did the odd ones. Because 9 is a little bit insane. And I figured we could do it together. All right, it says matching graphs. 9. Whew. Carrie, Luke, and Mason received the same allowance each month from their parents. That's nice. Carrie spent a small amount of her money in the first half of the month, then spent the rest in the second half of the month. So what would that look like on a graph? In the first half of the month, this one spent most of it in the first half and nothing in the second half. This one spent a little bit in the first half and some in the second half. And this one spent it evenly all through the month. So let's see if we can figure out which graph goes with which person. Carrie spent a small amount of money in the first half and then spent the rest in the second half. So this is Carrie. Luke steadily spent his money throughout the entire month. That means this has to be Luke. Mason rapidly spent all of his money in the first half of the month. Right? That means that has to be Mason. What kind of student are you when it comes to money? Are you a Mason, a Carrie, or a Luke? I'm going to go ahead and tell him I'm a Mason. And if you're a Mason now, you're a Mason for life, which means you're never going to have any money at the end of the month. You need to learn to either be a Carrie or a Luke. I'm just letting you know. Life lesson. Alright. So, you need to go back and read the even or the odd ones, no, even ones. Read them as many times as you need to figure out how to label the x-axis, label the y-axis, figure out where the points are going to go, and make your line. Right? Take your time. It tells you graph time on the x-axis, distance from the ground on the y-axis. Think about what it would look like visually to see something happening. Go back to the roller coaster. Why? Because it's easier to look at and be like, okay, I can visually picture it going up, down, flat, up, down, up, down. Like, try to imagine what it would look like visually. When you're done, bring it to me. We'll see what you got.